Hi, this is Brian Turow from the Perfusion program at MSOE, and I'm here today in the next video of my series for new perfusion students. And what we're going to be looking at today is the Cardiosave intra-aortic balloon pump by McKay. So the first thing we really need to do is to familiarize ourselves with the console here. So this is the back of the unit, and this is where most of the different connections are made, either for the catheter itself or for different electronic monitoring. So starting with the upper right here, this is the fiber optic sensor input. This is the ECG input and pressure input if you're using the monitoring off of the console itself. Down here lower you'll see these two ports, and those are for ECG and pressure monitoring if you're slaving off of say one of the large monitors. This is just the trainer port connected to the trainer unit, so we can kind of see some rhythms and things, so this will normally not be connected. This is where the catheter itself gets connected. So that helium tubing runs down to the catheter. And also important to note is the power button, which is right above this handle back here. So before we even bother turning the machine on, we need to check the helium gas levels. And helium is the gas that these balloon pumps use to shuttle back and forth to the balloon. And the way we check the helium is by checking the pressure gauge. And on this particular unit, the gauge is on the front. You can see it's right below the screen and kind of above this handle. I'm going to zoom in on this here. And you can see that the pressure gauge for this one is in the green, so we're actually okay. But just for the sake of showing you, the next step here would be to actually change out that helium tank. So now we're looking at the lower left-hand side of the console. You can see there's a picture of a helium bottle here. And to change this out is fairly simple. This side compartment pulls straight off, and then there's a little shelf here that pulls out. Now, before you remove this tank, you need to make sure that the helium is shut off. So you remove this little handle here and tighten this all the way to shut off the flow of helium. Make sure that's shut off, and now you can open up the hand crank. You will hear some gas being released as you do that. Alright. Now you can remove that and remove the helium tank. So now you grab your new helium tank, put it back in, tighten this back down, make sure it's snug. You don't have to, really crank it down, but make sure it's pretty snug. And then you can use this to once again open up the helium. You don't have to open it all the way, but a couple turns should suffice. And then you can close that back up. And of course, after you've changed out the helium tank, make sure that the pressure you're receiving is adequate. Okay, after we have verified our helium source and we have all of the connections made to the back, it's time to turn on the machine. So just press the power button. It will go through a booting procedure. After you have powered on the console, this is the top screen that you will see. Of course, we have this set up with the trainer, but you would see the patient's actual rhythm on here. As you can see, what we have is a normal sinus rhythm with a rate of 80. Here we can see the arterial pressure wave, and here is where we would see the balloon pressure, but of course that's not running yet. And in the lower right we can see our two battery power supplies and our helium source. This is the lower screen of the console, and as you can see, when you turn it on, it is set into auto mode, which means that the machine will decide when to inflate and deflate the balloon. It's also set to standby. Now, if you are using the fiber optic sensor that's part of the balloon, you can just start using the machine right away as is. If you are using a separate monitor, if your balloon catheter does not have the fiber optic connection, then you will need to zero your transducer. And you do that exactly the same way you do with every other transducer. You open it to atmosphere, and then to zero it, you will hold down this calibrate pressure button for 2 seconds. Now that the console is set up, you can actually start using the balloon pump. Now, if you are crunched for time, if you just want to get the balloon started, or if you just frankly don't really remember a lot about the more fine-tuning of the balloon, you can use it in auto mode. And the trigger response for auto mode is automatically set up to be ECG, which is by far the most commonly used trigger. And to start that, you can go ahead and just hit start. Now what it'll do, I have the catheter here, is it'll actually do a couple of autofills, as you can see. And the purpose of that is to fill the balloon and verify that the amount of helium that the console is sending to the balloon is the amount that it's getting back, just to make sure that there are no leaks. Once that has completed, now you can see it will start pumping. And you will see it pause here as well. Now it's kind of paused, and that's sort of to verify the auto settings. Next thing we're going to look at is fine-tuning this so that you have the most efficient use of the balloon for the patient. So to fine-tune the balloon so that it's the most efficient that it can be for our patient, we're going to want to manually change some settings. And it's a little difficult because of the way these screens are angled to show both at the same time. So I'm going to go through the lower screen settings, and then I will show you what happens when you manipulate those settings on the upper screen. So of course, if we want to get out of auto mode, we are going to switch to semi-auto by clicking that. Now we have several different options here. On the far left is trigger. If you select trigger, it will bring up a menu of a whole bunch of different options on what will be the trigger for the balloon to both inflate and deflate. Now by far the most common is ECG. So the balloon will, if it's in auto mode, it will decide, the software will decide at what point in the ECG it should inflate and at which point it should deflate. When we're in semi-auto mode, it will still work off of the ECG, but it will actually correlate to a spot that we have selected in the ECG to be the inflation and deflation point. Hopefully that makes sense. We can also set this up to trigger by pressure and a few other options. The only other one that really I think we would use would be a pacer, and that would be for sort of some extenuating circumstances. So ECG is the one that we're going to be covering. And again, this sources here, we can select where that information is coming from for the trigger. Now under IAB frequency, we can see we have a 1 to 2, 1 to 1, 1 to 2, or 1 to 3 are our three options there. And what this allows us to do is to set a ratio of trigger points to balloon inflations. So when this is set to 1 to 1, every time that there would be a trigger point, the balloon will inflate. When it's 1 to 2, the balloon will inflate every other trigger point. So essentially every other heartbeat. And with 1 to 3, of course, it would only inflate every third trigger point. Now this can be useful for a couple of different things. One is when we are setting up when we're tuning this to be the most efficient way possible, it's advantageous to be able to see what a non-assisted beat would look like. And then in addition, this can be used for weaning the patient off of the pump. You can start decreasing the frequency and see how the patient is doing. Here under augmentation, we can select the amount of augmentation or the amount of gas that's shuttled into the balloon. And here on the far right is where we are going to do most of our adjusting. Now this timing button, when you bring down the menu, you'll see inflation left and right and deflation left and right. So essentially the left would be earlier inflation, right would be later inflation, and the same for deflation. Okay, now we're looking at the upper screen, and I have the console set to semi-auto mode, so we have some control, some manual control, and I also have it set to 1 to 2 frequency. So you can see here that every other trigger point, the balloon is inflating. So there's a balloon inflation. And I'm going to start adjusting some of these manual settings so that we get to that most efficient point that I've been referring to. Now, there are some sort of acronyms and mnemonics here that will help you, and they might sound a little funny, but they do work. So what we want to do is, the safest thing for the patient is to have a late inflation but an early deflation. And the way you can remember that is by the acronym LIDE. So late inflation, early deflation. And the way you achieve that on the Cardiosave console, as you can see here, we have inflation on the left and deflation on the right. So obviously, the further to the right here that we go, the later the inflation is going to be. And the further to the left on the deflation, the earlier the deflation is going to be. So the way we remember that is fiddle to the middle is sort of the mnemonic that you can use. So what I'm going to do is I'm going to start using those buttons on the timing that I showed you before to start moving this inflation later and the deflation earlier. So you can see here I'm moving the inflation point to the right. And I apologize, it is a little finicky, or it takes a little bit. So I'm going to kind of just adjust that a bit to the right there. And now I'm going to do the same with the deflation, moving it to the left. So now effectively here I have achieved a late inflation and an early deflation. Now this is not by any means the optimal point for us to be at, but what it is safe for the patient. It's not really going to do much to augment them at this point, but it's a good, safe starting point. Now, the way we can adjust the inflation is we want the inflation to occur right at the dichrotic notch. So let me see if I can zoom in here. And you can see right here on the down slope, this is the, let me get on camera here, this is the dichrotic notch. And that's where we want the inflation point to occur. So I'm going to adjust that inflation timing so that it meets up perfectly with that dichrotic notch. Now one thing that we can do to help ourselves with that a little bit is there is a tool on the console called the reference line, which I'm going to use. So down on the console here, there's a ref line button. You can press that, and I'll show what happens up on the screen when you do that. You can move that line up and down. So if I come back to the console here, you'll see now there's this white line that's running across the screen. And if I move that those up and down arrows, that line moves up and down. So what I want to do is align that white line with the dichrotic notch. So I'm going to do that. And that seems about correct. So now what I want to do is move the inflation point so that the inflation occurs right at that dichrotic notch, which just is going to coincide with where that line is now. So I'm going to move the inflation earlier to adjust that to that point. Okay, now I have adjusted the inflation so that it occurs right at the dichrotic notch, and you can see that it's fairly V-shaped right at that point. Now, the white line helps us, that reference line, so that if we accidentally back up too far, let me just keep making that inflation earlier. You can see now we have a nice V in our dichrotic notch, but it occurs above that white line. So now we know we have moved that inflation too far, and I can bring it back so that it's perfectly in the right spot. So now that we have our inflation adjusted, it is time to adjust the deflation. And the way we do that is clearly our deflation is very early, and we want to start moving that progressively later until we reach the optimal point. And the way we see that is by looking at the diastolic assisted pressure here. We can see right now it's 44. And as we move that deflation later, we're going to start to see that diastolic pressure come down. However, once we get to a certain point, that pressure will actually start to come back up. And the optimal point that we're looking for is right when that diastolic pressure is at its lowest point for the assisted. So I'm going to start moving the deflation later. You can see it's now at 43. It's now at 42. Okay, it's back up to 43 again, now 44. So we know now we've gone too far. So we back it up, kind of more slowly now. Should be looking for roughly 42. There's a start of 42. Actually, now we're even getting a 41. And we're kind of looking for the center of where that 41 is going to be now. Now we're back up to 42. So a couple clicks back to the right, and now we're back at 41. Should be roughly centered on that. So now we have perfectly timed inflation and deflation, and this is going to be the most optimal position for this to be set at for our patient. Now that we have that set, back on the screen we can move the frequency into 1:1, and now we can see that we are getting an inflation on every trigger point, and this is optimally set up for our patient now. Now we have set the pump up so that it's working optimally for our normal patient, which the patient has a normal sinus rhythm, and the ECG is going to have a normal R to R. Occasionally, however, we have a patient with some type of an arrhythmia. Typically it's going to be an atrial fibrillation where there isn't an equal R to R interval. And the way these machines work is they have a sensed trigger point based off of the ECG, and then it calculates a time elapse for the deflation portion. So if a patient has atrial fibrillation, the inflation portion is still going to work correctly. It will still sense the dichrotic notch in the arterial pressure waveform. That will work just fine, but the deflation portion is going to be variable and will have a difficult time with that. Now there's a couple of ways that we can combat that. One is by simply pacing the patient. So if they have a slower heart rate, or a heart rate that we can control with a pacemaker, we can simply set them up with that, and then we can either leave it in ECG mode, or we can actually change the trigger to pacer. However, that's not always feasible. Sometimes you're not getting good mechanical capture with the pacer, or maybe their heart rate is too fast, or any number of different reasons why that might not work. So these machines also have a built-in what's called R-wave deflate, which is where if the machine senses an R wave, it will automatically deflate the balloon. So we're going to go into the settings and take a look at that. So what I'm going to do now is, you can see that the patient is in a normal sinus rhythm, but what I'm going to do is use the trainer to put this patient into atrial fibrillation, and we're going to see what happens. Now the way I'm going to have this set up right now is with the R wave deflation off. So I'm going to put it into atrial fibrillation. Now the patient's in atrial fibrillation, and you can see that that heart rate now is very variable, and the balloon is actually having kind of a hard time. It's sort of freaking out a little bit, having a difficult time deciding what to do. So what we're going to do here is pan down to the lower screen. If I can zoom out. We're going to go into preferences, pump options, and we're going to look at turn this R track option on, and that is the R wave deflate option. So we're going to turn that on, and now the pump will automatically deflate whenever it senses an R wave. And I don't know if it's kind of hard to tell just from hearing it, I guess, but the console is handling it much better now, and you can see down here that auto R wave deflate is enabled, and that is another way that you can manage a patient in atrial fibrillation. Well, I hope this instructional video on the Cardiosave balloon pump was helpful for you. As you may notice, nurses and other hospital staff tend to put these things in auto mode and let them go. I hope you become the resident expert on the balloon pump and get the most out of these machines for your patient, and also become a bigger asset in the operating room.